Jack? Number 15. Okay. So here we had x minus 5 to the 5/3 minus 73 is equal to 170. So we'll start by adding 73 to both sides. That gives me 243 on the right. And then I'm going to do the exponent 3/5 to both sides. Okay with that? That's going to give me x minus 5. And if I can do this just on my calculator, so I'm just going to do 243 to the 3/5 real quick. So 243, carry it up, and then just do 3 divided by 5. That gives me 27. And because I am doing an odd root to both sides, I don't have to worry about the plus or minus. So there's no plus or minus there. And then I just add the 5 over to get 32. And because this original problem is an odd root, not an even root, I don't even have to worry about checking it. So I'm just done there at 32. Does that feel okay, Jack?
Yeah.
Okay. Maya? Sure. So 1/7 x plus 9 to the 3/2 equals 49. So the first thing I'm going to do is get rid of that coefficient in front. So to cancel out that 1/7, I can either divide by 1/7, or I can just think about multiplying by 7. That's kind of the way that I'm going to do it. So if I multiply both sides by 7, I get x plus 9 to the 3/2 is equal to 343. So I will then take the exponent of 2/3 to both sides. That leaves me with x plus 9. And then I'll just go to my calculator and do 343 to the 2/3. That gives me 49. And again, I don't have to worry about the plus or minus because what I did to both sides was an odd root. And then the last thing, I just subtract 9 from both sides to get 40. However, the original problem is an even root, so I should check this. I'm just going to use my calculator to check it real quick, though. So I'm going to do 1/7 times, parenthesis, 40 plus 9 to the, 40 plus 9, close parenthesis, there we go, to the 3/2. And what I get back is 49, which is what's supposed to happen, so this answer is perfectly fine. Is that okay there? Okay. Yeah, you're welcome. Jack? The answer for number 12 was plus or minus 32? Sure. So we have 9x to the 2/5 equals 36. So again, the first thing I'm going to do is divide both sides by 9 to try to get that x by itself. So 36 divided by 9 is 4. Then I'm going to do the exponent of 5/2 to both sides. So 4 to the 5/2, I'll just do it on my calculator. And when I do that, I get 32. But I, again, notice that what I did here to both sides was an even root. So I do need to make sure I include that plus or minus. So you have to be very careful when you're using those fractional exponents. It's easy to miss that what you really did to both sides was an even root. And I know this is my final answer because the original problem is an odd root, so I don't have to check it. Jack, does that feel okay?
Yeah.
Okay. Did you do the exponent before you divided?
Yeah.
So just to reiterate there, if you contrast this with number 9, number 9 is, because of the exponent there, it looks like this. That's a situation where you'd want to undo the exponent and then divide, as opposed to this problem where we don't have that parenthesis around the 9x. It's just 9 times x to the power. For number, this was for number 9, you'd get rid of the exponent first, and then you divide. And that should be clear from the parenthesis there, right? Saying that the exponent has to happen before the multiplication would happen. So I tried to make sure I included that situation on there to help. I know students often get confused about which one to do first in that scenario where there's a coefficient. So that parenthesis is your indicator of which one to do first. Okay. Anyone else with questions from this assignment? I'm happy to do some more if we would like. Nathan? So I did 4 to the power 5 over 2, okay. And I just used my calculator to do that real quick. Okay. You could do it by hand also, but it's fine to use your calculator. Okay. Okay. Well, if there isn't anything else, we can move on to the next thing. Is that all right with you guys? How did this one go? Okay, I hope. So today we're going to continue talking about solving radical equations. But this time we have, the problems are going to get a little bit more complicated. I know. But not so bad that we don't know what to do with them. This is just part 2. We started talking about this last time. We're just going to continue talking about it today. So there's 2 situations that I want to talk about today. The first situation is where I have x's under my radical and also outside of my radical. So for example, if I have x plus 1 equals the square root of 7x plus 15. So this is the first time that, since we started talking about solving of radicals, that we've seen x's in 2 different locations, right? In all the previous problems we did yesterday in class and in last night's homework, we had only one x in the equation. Here we have x's underneath the radical and also outside of the radical. Do we all see that? Okay. So here, my strategy is going to be to get the radical by itself, which in this problem it's already done. Everybody agree with that? And then I'm going to cancel the radical, and then I'm going to try to combine my x's after that, and then solve the equation. So how am I going to cancel that square root? Squaring both sides, right? Everybody okay with that? So on the right-hand side, the square is going to cancel the square root, and we're going to be left with 7x plus 15. What do I get when I do x plus 1 squared? Is that x squared plus 1? No! So remember yesterday, we talked about this freshman's formula that's never, ever, ever true, right? What did you do to get x squared plus 1? You used that illegal formula there, that one that doesn't work. Well, it says I wrote a not equals sign in between it to show that it's not equal. Those two things, that's not okay to do. So what should I do to do x plus 1 times x, or x plus 1 squared like that?
Foil.
I have to remember that this is x plus 1 times x plus 1, and we should FOIL here. Exactly right. So what kind of a problem has this turned into? This is a quadratic equation, isn't it? Remember this from first semester? To solve a quadratic equation, what do we need to do first?
Get the x on all sides.
It needs to equal 0, right?
It needs to equal 0.
So I need to move everything onto one side. So I'm going to put it all onto the left-hand side. So I'm going to subtract 7x from both sides and subtract 15 from both sides. So now I have a quadratic equation that's equal to 0. What are the different ways we can solve a quadratic equation when it's equal to 0 like this? I can factor or solve directly if there's only x squareds or the quadratic formula. In this case, which one looks like the easiest route? Factoring. Hopefully you recognize how this factors. It should be pretty easy. Reminder that what we're looking for are the two numbers that multiply to give us negative 14 and add to give us negative 5. Those two numbers are negative 7 and positive 2. Everybody agree with that? So this can factor to x minus 7, x plus 2. And then to solve this, we just set each of those factors equal to 0, and we can solve. Is everybody okay to hear? But remember, what kind of radical did we have in the problem at the beginning? Square root. So what are we going to have to make sure we do here with these answers? Not plus or minus, because we didn't use a square root to both sides to solve this. But we do need to check these answers, because it's possible that not both of them work. Okay, so let's check the 7 first. So if I check the left-hand side, 7 plus 1 is just 8. And if I check the right-hand side, 7 times 7 plus, or the square root of 7 times 7 plus 15 is also 8. So 7 is a solution. Now let's check negative 2. Negative 2 plus 1 is negative 1. And then the square root of 7 times negative 2 plus 15 is positive 1. That one didn't work. Everybody observe that? So I'll just put an X through that one and box that one up with a check mark to show my teacher that I checked it. And I'll put an X through the other one indicating that I checked that one and it failed. Is everybody okay there? Let's do another. Yes?
So the first one we have learned to simplify, right? So that's it, just simplifying without solving.
Yeah, so in a simplifying problem, there's not an equal sign in the original problem. So there's no solving you can do. We write equal signs in to show that this expression is the same as the next one that we're simplifying it to.
Yesterday we solved from?
Yes.
But then what's the difference between yesterday and today? Today just a new way to solve?
Well, it's a different situation of solving. So yesterday you saw that the x's were always in just one location. This problem we have x's in like 2 different locations where we have some under the radical and some outside of the radical. So the approach here is going to be a little bit more complicated because of that. You're welcome. Ryan? Yes, of course. Let's do another. So let's try this one. What do we want to do first here? No, definitely not yet. Eventually, yes, but not right yet. So we got to square both sides to get rid of the square root, I think is what you meant, right? It was a weird way to say it, but I know what you meant. Okay. So what does the left-hand side become when I square both sides? Yeah, you get 10x plus 9 because we've canceled the square root with the squared. Good. And then what does the right-hand side become?
Squared.
We have to write it as x plus 3 times x plus 3 because we need to make sure that we FOIL that side out. So when I FOIL that out, I get x squared plus 3x plus 3x plus 9. And if I combine like terms on that right-hand side, I get x squared plus 6x plus 9. Now, Annalise, what is it time to do? Get it equal to 0. So I'm going to move everything to the right-hand side. So I'm going to subtract 10x from both sides. And then subtract 9 from both sides. So that gives me x squared minus, or 0 equals x squared minus 4x. Everybody happy to there? Okay. So again, we're left with a quadratic equation that's equal to 0. We said before the 3 major methods that we'd use to solve this are to factor, the quadratic formula, or in the case where there's just x squareds and not x's, we can solve that directly. So we can't use direct in this situation because we have x's and x squareds. Would it be easier to factor or use the quadratic formula for this? Well, I don't know about that, Holmes. This is a pretty easy factoring problem. Yeah, so the easiest route here would be to factor. You could use the quadratic formula. It's not wrong to do that. It works in every situation. But here I can factor just by taking a coefficient or a common multiple of x out of each term. So when I set each of the factors equal to 0, well, I get 0, and then I get 4. Am I finished? Got to check. So if I do 0, I can do this in my head really quick, right? Because I just end up with the square root of 9 equals 3. That's right. Everybody agree with that? So you could use your calculator to do that, but I don't really think it's necessary. Now let's check 4. And I'll use the calculator to do that because it's possible it could get kind of yucky. So I'll type in the right-hand side. And then the left-hand side. And we see that one worked as well. So is there an extraneous solution in this case? No. Everybody okay with that? All right. Let's do another. Let's try this one now. Notice this one's a little bit different than the previous problems we were working on, right? What's different about this one? Yeah, in this one we have x's in two different locations, but this time both the x's are under square roots, but they're different square roots, right? Everybody see that? So can I just subtract x from both sides right now since they're both under a square root? No, that is a good answer. That is not okay to do. What should we do instead as a first step? I would just square both sides. Notice what that's going to do. That cancels the square roots on both sides. And you're left with a pretty easy problem remaining, right? So I'll just subtract x from both sides. And then subtract 5 from both sides. But remember, since the original problem has square roots in it, we need to check this. So when I check the left-hand side, I get 3. And when I check the right-hand side, I also get 3. So this is an answer, and it's our final answer. Yes? Yep. All I do is I just type it into my calculator exactly like the problem looks. Once the left-hand side and then the right-hand side where I just filled in my number for x. That's all I'm doing. Just making sure they agree, right? So here is the left-hand side, but instead of x, I put a 2. And then I have the right-hand side is here, but instead of x, I put a 2. And I notice in each case, I got the same answer.
So like, if like the first case you got 3, the second case you got 2.
Then it doesn't work. That's extraneous, exactly. So I'm just checking to make sure the two sides match. I would just, so what I would do is I'd write my answer down, say like x equals 2 didn't work, and I just put a bit, cross it out. And then if it was the only answer, I just write no solution then. Is the way we would do that. Is that okay? Okay. Just like before where we got one of them that worked and one of them that didn't, I just crossed out the one that didn't and circled the one that did. If they both didn't work, again, you just cross them both out and write no solution. Yep. Yes. Of course. All right. Everything had been reasonably okay to now, right? Now things are going to get crazy.
It's actually crazy.
Mm-hmm.
Oh boy.
Yeah.
Oh, yeah.
So at first glance, this problem doesn't look too fundamentally different than the previous one, right? I have x's on both sides of my equation. Their x's are both under the radicals. Really, what's the only major difference between this problem and the previous one? Yeah, this extra thing being added to one side or the other, doesn't really matter, or both, creates some major headaches for us. Okay, you're going to see why in a moment. Just like the previous problem, I would start by squaring both sides. Now, on the right-hand side, no problem. Oops, the square just cancels the square root. But on the left-hand side, what do we have to do? I have to FOIL. Yeah. Because of the addition going on. Right, I have something plus 1. Right? So if I go back and I look, that looks fairly similar to this situation where we had to FOIL, right?
Yeah.
It's just now instead of an x, I have the square root of x plus 2, but then it's being added or subtracted to some. So we do have to FOIL here. So let's write that out so that we can have a form to FOIL. Does everybody see, though, why we're FOILing this time? And why that plus 1 makes us some headaches here?
There's like no way to get rid of the.
Not at the same time. Yeah. You're actually going to have to square both sides twice during this. I know, it's exciting. So if I do first, and I multiply the square root of x plus 2 and the square root of x plus 2, I'd get the square root of x plus 2 squared, right? Everybody agree with that? Then if I do the outer, I get the square root of x plus 2, because 1 times anything is itself. If I do the inner, I also get the square root of x plus 2. And if I do the lasts, I get 1. Is everybody okay there with how I FOILed that out? Okay. So I notice here that the squared and the square root are going to cancel. That's going to give me just an x plus 2. These guys are the exact same radicals, right? Everybody agree with that? So I can add those together to get 2 square roots of x plus 2. And then I still have that plus 1 hanging around at the end. Everybody okay with where we're at now? So my goal at this point is now trying to get this problem to look like one of these first 2 examples that we did, where I have the square root alone on the left-hand side or the right-hand side. Either side is fine. And then all the other stuff on the other. Okay with that? So I'm going to start by subtracting 1 and then subtracting 2 from both sides. And then subtracting the x from both sides. So 3 minus 1 minus 2 is 0. And then negative x minus x is negative 2x. Everybody okay there? I'm then going to divide both sides by 2. And now this looks remarkably similar to a problem like A or B that we just got done working. So what do you suppose I'm going to do now at this step? I'm going to square both sides again. Yeah. So that's going to give me x plus 2 equals x squared. Okay with that? What we have now is a quadratic equation. To solve a quadratic equation, what do I need to have happen? It must be equal to 0. So I'm just going to subtract x and negative 2 from both sides. So I get 0 equals x squared minus x minus 2. To solve this quadratic equation, how do you want to do that? Remember, we had 3 choices. We can factor, we can use the quadratic formula, or we can solve directly. Yeah, this factor, so let's try doing that. So the two numbers that multiply to give us negative 2 and add to give us negative 1 are negative 2 and positive 1. Everybody okay there? If I then set each piece equal to 0 and solve, I get positive 2 and negative 1 as my 2 solutions. But I'm not done. What do I still need to do? Still need to check. So let's go back to the original problem here, and we'll check the positive 2 first. So I have the square root of 2 plus 2, and then a plus 1 after that. And then on the other side, I have the square root of 3 minus 2. That didn't work, right? You notice that I got 2 different answers here. So 2 is extraneous. Let's cross that out. Now let's check the negative 1. So we have the square root, negative 1 plus 2, and then a plus 1. And then I have the square root of 3 minus negative 1. Also gives me 2. Notice because that, both sides agree, they're both equal to 2. That answer is acceptable, and it's our only solution. Should we do another like that? Yeah, that's not a tremendously easy. So I'll tell you in a second. Yep.
Oh, okay.
Annalise, it's for you.
I'm sure.
Bye, Lexi. Okay, so just to overview of what we did here before we do the next example to help you guys maybe visually see what the plan is here that we're doing. So we have radical plus constant equals radical. And what we're going to do is we're going to try to get that into radical equals x plus constant. And we're going to take that into a quadratic, and then that we can get our solution from. So that's kind of the idea. We start with a radical plus a constant equals another radical. We're going to square both sides and do some rearranging to get it down to a radical equals some x's or x's plus a constant maybe. And then we're going to take that by squaring both sides down to a quadratic, which we can then solve. So that's just kind of the general idea here. So figured before we do this again, a little brief overview of kind of what the plan is would be helpful. I think, what letter are we on? Are we on E? Okay. Oops. 2 minus 2 equals. Okay. All right, so square root of x plus 6 minus 2 equals square root of x minus 2. What should I do first here? Okay, we'll square both sides, which is going to cancel the square root on the right-hand side. What do I have to do for the left-hand side, though?
Add 2 to the other side?
No, I have to FOIL.
Oh.
Yes, of course. Is everybody okay with that first step? Okay, so let's do the FOILing. Square root of x plus 6 times the square root of x plus 6 is just going to be x plus 6, right? Because we have the square root of x plus 6 squared, and the squared cancels the square root, da-da-da-da-da. Is everybody okay there? I skipped a little bit of a simplifying step there, but it's that same simplifying every time you do one of these problems. So then I did this, so I did the outer, so I have negative 2 times square root x plus 6. If I do the inners, I get another negative 2 square root x plus 6. And if I do the lasts, I get positive 4. Everybody okay there? If I combine like terms on the left-hand side, I get x plus 10 minus 4 square root x plus 6 equals x minus 2. Everybody okay here? So I'm going to go ahead and move everything on to, or I'm going to try to isolate the radical. So I'll begin by subtracting x from both sides, subtracting 10 from both sides. And something very nice has happened there. What do you notice happened? I don't have an x. That makes this problem not like those first two that we looked at today, but like the problems from yesterday, where we're going to get to avoid having to solve a quadratic here. That's pretty nice. Does that usually happen? Probably not, but it could, as we're seeing here. Okay, so just like a problem from yesterday, we'll just divide by negative 4. That gives me 3. And then we can square both sides. So I have x plus 6 is equal to 9. And when I subtract 6 from both sides, I get 3. The last thing I'll do is go and check this. So when I check the left-hand side, I have the square root of 3 plus 6, and then minus 2. And then when I check the right-hand side, I have the square root of 3 minus 2. Since those two agree, I know this answer is correct, and it's my only answer. Everybody okay here? So we're going to stop here for today.